Grüezi miteinander. Thank you, Laurent, for graciously inviting me to speak to my colleagues here. But if you recall, a couple of years ago, maybe 3 years ago, when we were discussing about the recent failures in Turkey, the videos of which were circulating on the internet, he told me that I should talk about these to you. And at the time I told you that the thing is, engineering-wise, is that we are learning nothing, okay? So, but now, when I see the list of speakers and the topics they are talking on, I understand why he invited me, because this is like a relief from engineering, the examples of what you will see. But I will show you the consequences and why these are happening. What I am going to show you are actually exceptions, rare cases, but in a so rapidly evolving construction sector in Turkey, even in many projects, some fail and those amount to several in time. In Turkey, the guilty party is generally considered to be the one who is late in finishing up the project. And that goes on also for public servants who are called on to explain the reasons of failure. And unlike the previous examples, they call on you. For example, they say, okay, the minister is waiting for you. And they generally ask this to professors or so. And then they give you about an hour or two to explain the reasons. And unlike the previous cases that you have heard about until now, it's not a difficult job, the good thing is. Because if you use the analogy of a detective, the previous ones are working like Sherlock Holmes and they see small details, they use their knowledge and wits. But here, as I'll show you, in some cases, and these are not confined to Turkey or Istanbul, you can see them all around the globe. This will be an interesting experience maybe for you to see failures that you will not see in your country. And when you go there, the thing is, it's like a murder case, but the thing is, you see the killer there with the knife in his hand, another one covered in blood, the footprints are going somewhere, so you don't need much. So let's see what I'm talking about. Of course, soils are difficult materials, complex materials. They change with time, stress, and temperature. It needs to draw on its sister disciplines such as structural engineering, hydraulics, construction materials, even construction management. And as a result, as engineers, you know, we try to simplify things. We make assumptions. We conservatively design. And at the end, actual factor of safety is always exceeds nominal factor of safety. Yet failures still occur. And these can range from minor serviceability exceedances to catastrophic failures. And we can learn from all of these, but not everything we will learn will be about engineering. And even learning from failures will require a systematic approach. Sound design and construction principles, clearly defined roles and responsibilities, and it will require careful monitoring, documentation, and an open exchange of information and professional experience. If any one of these are missing, then failure is more likely. But the thing is, if all of them are missing, failure is inevitable. And when these failures occur, and nowadays, of course, anyone has a camera with them, and they are documented, then the authorities do not feel good about it, and they feel that they need to do something. And what they do is that they generally issue or amend regulations. They change standards. They can alter building permits and even change zoning plans, which I'm talking about. And this stems from a confusion between engineering design and construction activity. And at the end, the net effect is constraining engineering judgment in design, which is not helping. And I'll show you from this slide on some examples of failures. These will range from retaining wall failures to embankment failures to foundation failures. I could have found even more, but I have selected some cases to go over when discussing the causes of these. And when any one of these failures occurs, people are called onto the site and they want to explain the reasons underlying them. And when I will be showing these failures to you, because of confidentiality, I will not give the exact locations and I cannot give the project names. Without this confidentiality, open discussion here wouldn't be possible. And that in itself shows the lack of transparent information sharing that our profession direly needs. But unfortunately, I cannot name the locations. But here, I should emphasize that, I should highlight that most of the projects in Turkey are completed successfully, even the most difficult ones, because there are highly skilled engineers, very competent consultants, contractors, but systematic problems can also come to the aid of incompetent ones. And these are the actual reasons for failure. And the failure cases I will talk about, they have one thing in common. They have almost non-monitoring or instrumentation by which we can track what happened. But luckily, they are easily distinguishable to the naked eye. And the thing is, retaining wall collapses are among the most hazardous and visually striking forms of geotechnical failures. As you can see here, I had to visit this one as well. It was unfortunate. This was in Istanbul, Kağıthane region, not the exact location again. And even from these cases, we can see the problems with the system. These are some photographs from this collapse. And there are many contributing factors, not only one. As I told you, any single issue can cause collapse, but we have many problems associated with these projects. And of course, at the top of the list is always inadequate construction practices. And there is also insufficient site supervision. When you visit the site, you directly see that. You can see the poor construction quality. Is this laser? No. Oh, sorry. Am I going back? Yeah. And hopefully you can notice the reinforcement that sticks out from the shotcrete or the quality of the anchors or soil nails. I couldn't put all the photographs here, but first of all, construction quality was poor. And incompatible systems were used. For example, anchor plates were placed on uneven shotcrete surfaces. And the retaining system even was not continuous. It started as an anchored wall, continued as an anchored shotcrete, then turned into soil nail wall without the benefit of any veilers or support beams. On top of that, the construction opened for an extended period of time, even though this was not a permanent retaining structure. And during that period, contractors changed and subcontractors changed as well. And additionally, on top of all, when you look at the projects and what's constructed at the site, there were deviations. And these show that there was no oversight and there were many accountable parties, but the accountability was blurred. And even though, as an engineer, you can report why this happened, later, legally, binding someone to this problem will be almost impossible. Another failure case, again, this is from Istanbul. And why these are generally from Istanbul? Because most of the deep excavations are conducted in Istanbul. Here you can notice, for example, beams are not continuous. On top of that, even some piles do not extend all the way to the bottom of the excavation. They did not construct the last beam or the anchors, and the retaining structure showed signs of distress. That's why there is a makeshift embankment back here to stop the movement. And maybe you can notice, let me go back and forward again. And there is over-excavation to speed up the construction. Why? Because the time is critical, time is money. Therefore, there is always pressure on contractors to finish the job early. Therefore, they excavate early and generally ignore the last layer of anchor. They think that, okay, I will construct the building, then I will not need the last layer of the anchor. And the concern who is recording, the concern of the person who is recording is the cars at the top here. Another one from Istanbul again, close by to the region of the previous failure. And by the way, Istanbul's population far exceeds that of Switzerland as a city. And the land is extremely precious, therefore there are many buildings with basements. And the number of these projects is constantly increasing. That's why the cases are generally from Istanbul. Here, please note, additionally, that the same problems also persist here. But on top of that, you will note that even though this wall was coming, maybe from the sound, actually I'm speaking over it, but maybe from the sound, you could have heard the anchors popping. And if you are careful, you will see soil spurting from between the piles, showing that the soil arches that transfer loads are disintegrated. And this wall is coming, but still there are people underneath. That shows the absence of vocational training, safety training, and these are crucial. Okay, there can be failures from time to time, even in ones that are carefully planned, as we have seen before, but safety training is critical. And the next one is interesting. Luckily, generally, no one is injured in these cases. So we are lucky. And now, in the next one, here you can see two guys, two curious Georges. They are leaving the excavation site at the end of their shift, and they are walking up the service ramp of this excavation site. Here you can notice the movement of the soil. This is a slope instability, not a retaining structure failure, but slope instability. But then they are curious. What's going on there? They need this. One of them then changes, but one of them goes towards the failure. This is just to show that security training is critical. And this project, it had many other problems, but I don't have the time to show them. Another one, the problem is obvious here. There's a water problem, but in this second case, in particular, this excavation. This project belonged to a famous football player who played in Barcelona or so. And you can notice that wall is not continuous. They are constructing the wall after they complete that stage of the excavation to save time. The wall is just a show there to show that there's a wall. Again, anchors are popping, and you can see the plates are attached to sort of makeshift beams that are not carrying anything. And we call these struts psychological struts so that people will save as they are working in the excavation. And the wall is not continuous. There is not a benefit of a socket. And at the end, from the sound, you cannot understand that, but the concern is now the equipment there, the machinery. They are concerned about it. And one of them says, call the consultant, and another one says, that building is gone. Of course, that's demolished after that. So, what are the problems and what are the challenges now? First of all, regulatory framework. The regulation in Turkey does not recognize licensed engineer or professional engineer. Therefore, legally, according to regulation, there is no distinction between a fresh graduate and an engineer with decades of experience. So that's to the benefit of some contractors who can hire fresh graduates on safety critical projects, even on safety critical projects. And the absence of licensing is a big problem then. And there are many fresh graduates who are eager for getting some jobs. And there are inspection and responsibility gaps, as you have noticed clearly. And professional roles are not well defined. For example, last night we had a dinner. I told that the professional roles of structural engineer, geotechnical engineer, geologist, geophysicist, even geophysicist, they all overlap according to regulation. Because they have some, each of them have some lobbies, and there are human resource and competency deficiencies. The unskilled foreman or a subcontractor can decide on what to do at the site. And additionally, there are administrative and legal shortcomings, such as when these failures happen, the local authorities lack the technical knowledge to define what happened and how to control it. And as a consultant, when you visit, not during a failure, but for a project, to the local authority, they generally ask you what they should do. If you see that you are a professor or a faculty, they ask you, then you explain that. You should check this, you should look at that. Then you teach there. But of course, some people can use that to their advantage. And there are, of course, poor construction quality. You can see this. It shows that there is no oversight in these projects. And of course, there are market pressures. Economy affects these, and market pressures force contractors to finish quickly, to cut corners. And these are the regular problems we face. Now moving on to embankment failures. And by the way, at each section, I put some photographs from other projects that are, most of the projects that are successful, but those ones that fail, they are more interesting to look at, of course. And embankment failures occur from time to time. The thing is, as you know, transportation infrastructures are known for their linear and long footprint, which makes certain that at some point or so, an embankment will trespass soft soil conditions, and that requires diligent and careful site investigation, soil investigation, which adds an economical burden on the project. And contractors, of course, do not like that. And additionally, embankment constructions, transportation infrastructures are under pressure from political or they are under pressure politically and economically. They are asked to finish on time and even before time. Generally, for these projects, who wins the bid? Our president, with a ceremony, congratulates them and tells that, okay, you promised for 2028, I'm waiting for 2027. They can say, no, okay, yes, sir, and then they are bound with that. And that causes a huge problem. And additionally, bidding method is a problem. As a bidding method, unit price contracts are commonly preferred in Turkey. And in unit price contracts, generally, soil exploration is seen as an economic burden, especially in problems where the employer or a consultant completes the design prior to tendering. Then the contractor, unless explicitly required by contract, has no incentive to expand exploration or to gain higher quality data, because that's an additional burden. And that causes, especially when soft soils are traversed, they might now not know that they are traversing soft soils. Even if they know, they say, let's design considering worst case scenario or so. Then that results in mismatches in design, which can also cause problems, either serviceability problems or internal problems. And if nothing is considered, there can be global failures, as you see in the last two photographs. The first one is a serviceability issue for us, but yeah, the others are complete failures. And why do these occur? Common reasons are poor quality fill materials can be used. These are actual photographs from the showing which type of materials can be used in fills, and insufficient compaction or correcting it as they fail. These are some practices that can be seen in these problems and in these projects. And these projects can be designed with inadequate support systems based on unit price contracts where the focus is quantifiable construction elements. Then soil investigation, again to repeat, is a burden. And if you do not know about the soil well, then the design might not be correct for the location. Additionally, some, for example, some contracts ask you to use only CFA piles. You say, this is not correct for this problem, but then the contractor will not get paid. These problems result in global failures. And additionally, in some projects, hydrological regime might not be taken into account. This is the train wreck from Çatalca about 6 or 7 years ago. And these embankments disrupt the natural flow of water. And if culverts are not designed properly, or if they are undersized, then erosion might occur. And in extreme cases, ballast might wash out. And as a result, these types of failures can happen. Additionally, if you do not consider the hydrological regime when setting the elevation of the embankment, then the region can be flooded. This is the same location, before and after. Or if you do not correctly calculate settlements, then the highway can remain underwater. And an important point is that we have seen these for many embankment failures, that they show signs prior to failure. If you use a tool like Google Street View or so, and look at the point, previous conditions, you will notice signs of failure. either you see the sign directly or you see that that's now being, they are making it up, pouring some asphalt on it or so. So they show signs, and it shows the importance of proper monitoring. And I think even satellites can be used to monitor these, monitor the transportation infrastructure to avoid these problems. And of course, I've only talked about static failures under static loads. Of course, under earthquakes, embankments can fail significantly. These are after the 2023 Kahramanmaraş earthquakes. And you see the state of the embankments. This is a region near Gaziantep in southeastern Turkey. One thing we have observed is that conventional embankments failed generally. These were huge couple earthquakes. And reinforced earthquakes performed much, much better. That's an observation from these. And finally, regarding foundation failures are generally associated with earthquakes. But sometimes, especially when there are soft soils, foundations can fail, or you create serviceability problems that approach failure. And in Istanbul, as I told you, it has a huge population also, and the seismicity is extremely high in Istanbul, and therefore there are ongoing urban transformation projects. And in those projects, demolishing and rebuilding is done at the very same sites. And if those sites have soft soils, and additionally considering the tendency to construct larger and bigger during urban transformation, generally we need to improve the soil conditions. And even soil improvement works might be planned carefully, otherwise they will create failures. And on top of that, some buildings are historical buildings, and they require careful attention. Many remediation works were completed carefully and successfully. This is one such example. This is Limanhan, for example, in Eminönü, in Istanbul. This is before photograph. This is the first reinforced concrete of Turkish Republic. Therefore, it has national significance. But on top of that, there are very nice China tiles on its front surface. And the thing is, my great-grandfather designed these tiles, and luckily I was there as a consultant during the remediation work. But not all structures are lucky like this one. There are some exceptions, hopefully not for historical ones, but we have some issues with other structures I will show in the following slides. But here, these photographs is to show you where we are working generally when we are designing foundations or retaining structures in Istanbul. You can see it's very densely populated, which creates logistical challenges. There are many buildings nearby, and they are in poor condition. Therefore, under those circumstances, the likelihood of mistakes increase. And this is an interesting one. This is near a deep excavation, and because of soft soils during this urban transformation work, they were trying to improve the soil. There was high volume grouting, and due to high volume grouting in very soft, saturated soils, building neighboring the region started translating and collapsed into the one next to it. Got through the wall, half a meter or so, and they are staying like this anymore. I don't know if they demolished them later or so, but soil improvement works are critical. And these are under static conditions, human-made. But of course, most of the failures occur during earthquakes. And these photographs and video are from Adıyaman Gölbaşı district. Gölbaşı literally means, in Turkish, literally means by the lake. From even that name, you do not need soil exploration. You will judge that there can be a risk for liquefaction here. So there is huge liquefaction risk, and almost all buildings here suffered liquefaction. Some of them collapsed entirely, some of them tilted significantly, even dropped onto the next building. Some of them settled significantly so that some cars are sandwiched between the pavement and the building. And the thing is, almost none of these buildings were constructed with piles. They didn't construct piles because even though site exploration showed it, the designers didn't think that this is a risk, maybe, because we don't know what they thought. There was only one building with piles, and that also showed differential settlement. Then after demolition and excavation, we learned that they constructed the piles short because it was more expensive. If they constructed 5 meters longer, nothing would have happened there. And so we have some challenges. I've gone over them in these slides. But again, to repeat, I'm showing you the failures, but there are many, many examples of success. And construction companies worldwide are known to finish safely and on time. And they are used to working under budget constraints. But if the system is not correct, they can work anywhere. In Europe, in the United States, they are working anywhere, really. But when the system changes, things change. So first step is the system. So for you, preserve your system. For us, we should correct it. This is an ongoing process. And we have domestical challenges, aggressive competition, of course, that's a result of economy, problems with economy again. Licensing problems is a huge issue, which is actually connected to competition because contractors have lobbies, and these lobbies do not want professional engineers, which will increase the economic burden on them. And subcontractor dependence is a problem. There is fragmented subcontracting, which blurs accountability, and there are ambiguities in responsibility. Who is responsible for what? So these must be corrected. I should talk about this in Turkey, actually, but I'm talking about that here. Of course, there are some responses to correct these, to alleviate these. The first one was the 2018 Turkish building design, earthquake building design code. This was a milestone. This was a milestone because it was the first earthquake-resistant design code that introduced geotechnical design. And but it was criticized severely by the engineers because of its heavy emphasis on complex soil structure interaction analysis. It required extremely complex analysis, but the thing is, we generally do not have access to such detailed data to make this valuable. So it's just an analysis with assumed parameters, a detailed analysis with assumed parameters. That doesn't make sense. You need to stay on the safe side. And because of that, contractors started to use workarounds. For example, pile drafts required soil structure interaction analysis. Therefore, do not connect piles to the foundation. They were constructing unconnected piles or piles that are unreinforced, which beats the intention of the code. That is to increase earthquake safety and resilience. For excavation support regulations, in 2019, the authoritarian response was to give a mandate to the public about the construction of excavations, which was highly rigid and regulatory. And For example, it asks to conduct consolidated drain triaxial tests every 2 meters of excavation for all walls. But the thing is, for many regions in Turkey, there are no laboratories with triaxial equipment that can conduct consolidated and drain tests. And if they do, they take very long time. And therefore, this was not congruent with the capabilities. Therefore, it even resulted in projects that are being changed and constructed without basements. And later that was replaced by a more balanced natural regulation. And I was at the committee that have written that. And for now it's going good. But the thing is, we cannot change things only on paper. And so there was also authoritative responses, such as after the earthquakes, of course, without piles, buildings on soft soils collapsed or suffered problems. And the government decided that, okay, we shouldn't construct on soils. That's not an engineering decision. They said we will construct only on rocky soils. And now they are constructing new buildings in the southeastern region only on rocky slopes. And sometimes they call us and the engineers there, they are saying, okay, we are now ballasting rock using explosives. Now we are constructing the buildings, but from time to time, rock is falling on us. Can we construct something to stop this? So they create their own solutions. If you do not, authoritative solutions never work. And additionally, it's a burden on, again, economy. That's the worst thing for them. Constructing lifelines or transportation networks is much harder now on rocky slopes. So conclusion, well-intentioned regulations often backfire if they are too rigid. And sector is good, okay? I have to say that. And failures are rare, but they are highly visible nowadays. If there is a failure, everybody sees it. And it has a major public impact, which is a problem because people do not know, they cannot distinguish good project from a poor project, poor design. Therefore, it has a negative impact. And last point, the lesson is prevention requires comprehensive multidisciplinary approach. Purely technical fixes and rigid regulations will not work, do not work. Thank you for listening.